We'll get started. Hi, everyone, and welcome to our webinar on remote monitoring and control of industrial air quality systems. Today, we will focus on our products and solutions. Our agenda for this webinar is to introduce the components of an air quality monitoring system. We will show you how to monitor airflow and ventilation. Then we will give you an overview of our air quality monitoring products, followed by some applications for these products and solutions that will broaden the scope of how these products are used. I wanted to share a little bit about who we are. ICP DOS was established in 1993 and is headquartered in Hsinchu, Taiwan. Later, ICP DOS USA was launched in 2001, and we are headquartered in Houston, Texas. A few benefits we offer our customers are fast service, free technical support, which is 100% US based, free software, fast shipping, and warranty on our products. What is an air quality monitoring system? An air quality monitoring system is a sophisticated network of devices and sensors designed to measure and analyze various pollutants and environmental factors in the air. These systems play a vital role in assessing and improving air quality, safeguarding public health, and protecting the environment. An air quality monitoring system consists of several key components, such as each with a specific function. Sensors play a crucial role with particulate matter sensors, detecting fine and coarse particles that can cause respiratory issues, while gas sensors measure harmful gases like nitrogen dioxide, sulfur dioxide, ozone, carbon monoxide, and volatile organic compounds. Meteorological sensors monitor weather conditions such as temperature, humidity, wind speed, and direction to understand how they influence air pollution. Data acquisition units, known as DAUs, collect data from these sensors and transmit it to a central monitoring station where data processing and analyze software processes this information to calculate air quality indexes, AQIs. They generate reports, visualize trends, and predict future air quality conditions. Finally, communication networks enable data transmission from the monitoring stations to a central control center for analysis and informed decision making. Together, these components work to provide a comprehensive and accurate picture of air quality and manage the environment effectively. Environmental monitoring tracks air pollution level areas to identify pollution sources and implement control measures. It also plays a key role in public health by assessing the impact of air pollution on human health. In climate change research, air pollution is studied to understand its effects on the environment and to develop mitigation strategies. Industrial monitoring ensures that air quality in industrial areas complies with environmental regulations. Additionally, indoor air quality monitoring focuses on improving air quality in homes, offices, and public buildings, which is crucial for enhancing human health and well-being. One of the simplest applications is remote monitoring solutions. ICP DOS offers environmental sensors, data acquisition equipment, and can help create and implement an entire solution or fill the missing components to help make more informed decisions. This solution has an array of sensors and DAQ modules to collect the data. The Modbus data concentrator helps to consolidate data from an array of sensors and pass the data to AVEVA Edge to create a report and send alarms through cellular GTM module in the form of an SMS message. Airflow and ventilation monitoring is essential for maintaining a healthy, comfortable, and energy-efficient indoor environment. By tracking airflow patterns and ventilation rates, these systems ensure that air moves effectively throughout a building, preventing the buildup of harmful pollutants, controlling temperature and humidity, and promoting good indoor air quality. This type of monitoring typically involves the use of sensors that measure factors such as airspeed, temperature, and humidity, which are then used to adjust the operation of ventilation systems like fans, dampers, and HVAC units. Continuous monitoring allows for real-time adjustment to airflow, ensuring that areas with poor ventilation or high pollutant levels are promptly addressed. In addition to improving air quality and occupant comfort, airflow and ventilation monitoring also helps to optimize energy usage by ensuring that systems only operate when needed, reducing unnecessary energy consumption. The CL series HCHO, TVOC, CO, CO2, temperature, humidity, and dew-point data loggers from ICP DOS are advanced air quality monitoring tools designed to track key environmental parameters like formaldehyde, volatile organic compounds, carbon monoxide, carbon dioxide, temperature, humidity, and dew point. These data loggers provide real-time monitoring and help identify pollution sources, ensuring optimal indoor air quality. Paired with the iAir app, users can remotely access and visualize data on mobile devices, making it easy to manage air quality and make necessary adjustments. Together, these products offer an efficient IoT-enabled solution for maintaining healthy indoor environments. PoE devices can also be easily incorporated into SCADA and controls for factory automation. The iAir app offers powerful features for managing air quality monitoring systems. It allows users to retrieve real-time data from DL, CL, and ISN series modules and provides group management for those devices. This app enables users to search for modules on the local network and offer remote control of the DL300 series modules. An air quality evacuation system is designed to protect occupants by monitoring air quality and automatically triggering actions like ventilation, air purification, or alarms when pollutant levels exceed safety thresholds. ICP DOS products, including air quality sensors, such as those measuring CO, CO2, PM2.5, and VOCs, data loggers, CL and CL series, and SCADA systems like AVEVA Edge, form the core of such systems. These devices continuously monitor environment parameters, transmit data to a central system, and trigger automated actions. For example, when sensor data exceeds predefined thresholds, the system can activate ventilation fans, air purifiers, or send evacuation alerts to ensure safety. Additionally, data loggers like the DL series collect and store data from sensors, allowing for real-time analysis and historical trend analysis. The iAir app further enhances system usability by enabling remote monitoring and control, allowing users to view data, receive alerts, and control connected devices like fans or HVAC systems from anywhere. This level of automation and remote control helps maintain safe air quality levels, optimize energy usage, and ensure timely responses to hazardous conditions, making it an essential tool for industrial, commercial, and public spaces. The ICP DOS ICANN series is a powerful tool for integrating air quality monitoring and notification systems. By enabling real-time data collection, automated responses, and timely notifications via SMS, email, or app alerts, it ensures quick action to mitigate air quality issues. Whether used to activate ventilation systems or alert staff to dangerous conditions, the ICANN series helps maintain a safe, healthy environment while improving overall air quality management. Monitoring air quality in mining and marine applications is crucial for ensuring the safety and well-being of workers and crews. In mining, air quality monitoring helps detect hazardous gases like carbon monoxide, methane, and particulate matter, which can pose serious health risks or trigger explosions. In marine environments, the air quality systems monitor pollutants such as VOCs, CO2, and oxygen levels to maintain safe breathing conditions for crew members. By using real-time sensors and automated control systems, these industries can detect dangerous air quality issues early, trigger ventilation systems or alarms, and ensure compliance with safety regulations, ultimately protecting lives and preventing accidents. Our GLW mini-series weather stations offer a range of features including multiple sensor inputs for monitoring parameters like temperature, humidity, wind speed, and rainfall. These stations support remote monitoring whether alerts, and can be integrated into SCADA systems. They are ideal for environmental monitoring in various applications, including agriculture, industrial facilities, and smart cities. ICP DOS offers advanced solutions for greenhouse monitoring systems, including sensors for measuring temperature, humidity, CO2, light, and soil moisture. Their data loggers, like the CL and DL series, collect real-time data, while automated control systems can manage ventilation, irrigation, heating, and lighting based on environmental conditions. These systems can be remotely monitored and controlled via SCADA platforms or the iAir app, enabling efficient energy-saving operations. By optimizing growing conditions and conserving resources, ICP-DOS solutions help increase crop yields, improve sustainability, and reduce operational costs in greenhouse environments. ICP-DOS offers CL and DL series sensors for industrial exhaust emissions monitoring, measuring key pollutants such as CO, CO2, NOx, and particulate matter. The CL series provides high-precision monitoring for gases like CO and VOCs, while the DL series focuses on real-time data logging for various environmental parameters. These sensors feed into ICP-DOS data loggers, which can be integrated with SCADA systems for centralized monitoring and compliance. This solution helps to optimize emission control, improve air quality, and ensure regulatory adherence. AVEVA Edge SCADA offers real-time monitoring and control, integrating with air quality sensors to track parameters like particulate, temperature, humidity, and airflow. This enables organizations to ensure compliance with air quality standards, improve health and safety, and optimize energy efficiency. Using AVEVA Edge to gain insights into their environmental conditions and make data-driven decisions for enhanced safety and performance. Here are some example application architectures that can be deployed using AVEVA Edge. In this control center application, we have data from the DLW weather stations, some environmental data from 2 of our DL modules, and the final 2 modules at the bottom are used for control of lights and fans. Above that is our WISE 5231 controller with an XV107 I/O board to control a few additional lights and fans. The WISE module will pull data via Modbus RTU from all of the devices along the bottom rung, and based on programming of rules, controls the fans, lights, and ventilation based on weather and gas particle levels. AVEVA Edge will monitor the WISE controller via Modbus TCP and send notifications and additional alarms if necessary. This entire architecture can easily be added to any other control system as well using Modbus TCP. This application here expands upon the previous application diagram. This one adds our Zigbee converter along with several Zigbee I/O modules. At the bottom, monitoring tank data. Zigbee repeaters are used to extend the communication distance where necessary. AVEVA Edge is connected via Ethernet to the ZT2570 and pulling data from the tanks via Modbus TCP. Again, the Modbus TCP data can also be shared to other systems. Other PLCs, HMI, other controls can be connected to AVEVA Edge for controlling and monitoring. One downside to using too many Modbus RTU devices is their polling rate can be slow if there are too many devices or communication errors. In this application, we show many Modbus RTU DAQ modules collecting data from various sensors and thermocouples on the shop floor. We add a Modbus data concentrator to pull the data from the factory floor. The MDC will continuously pull the assigned registers at a set priority and store the data in its own memory to pass to the control center via Modbus TCP. The MDC data will be combined into a new register map. This way, the Modbus TCP master, AVEVA Edge in this case, will be able to pull the data using a few polls, since the data will be in sequential order. The alternative without the MDC would be the need to pull each slave device independently. Our WISE 5231 is an edge controller capable of sharing data via MQTT to cloud platforms such as Microsoft Azure or IBM Bluemix. In this application diagram, we use our IoT software so that you can create your own local cloud platform without any added monthly cost. The edge controller will pull data from the water quality sensor, flow meter, and pump controller via Modbus RTU, and will also connect our alarm siren module to sound audible alarms if the sensor level becomes too high or too low. The cloud data will be shared to other devices or controls for further monitoring. This final application uses our UA series controllers to connect directly to the cloud via MQTT. The UA series collects data from the Modbus RTU devices through its RS-485 port, Ethernet IP, Modbus TCP, or MQTT devices, and pass the data to the desired cloud service. When used for monitoring environmental or safety situations, can be incredibly valuable, and the data can be used to predict hazards and prevent dangerous situations. And I believe that's it. This is our contact info. That's it for today's session. Thank you so much for joining me. We will look forward to hearing from you and hopefully seeing you right here for next month's training, which will be our last one for 2024. Thank you so much, everyone, and have a wonderful rest of your day.